Dear rail lovers, welcome back to Railways Explained. In case you're for the first time on the channel, here on Railways Explained we are basically dealing with many different railway topics, including railway infrastructure projects, railway systems of different countries, railway rolling stock, railway technologies, railway market, and many other. If you're interested in these topics as much as we are, hit the subscribe button and turn on the notification bell so that you won't miss any of the future videos. For today, we have prepared a very interesting story about the development of the Spanish high-speed rail system. We remind that in the previous video we spoke in detail about the Spanish railway system, its historical development, the reform of the old Renfe company, and of course we discussed the traffic indicators and the Spanish railway market. As a continuation of that story, and before we start drawing high-speed lines on the Iberian Peninsula, let's first mention some details specific only to this system. Just as the French high-speed railway is special in its interoperability with the conventional railway network and being exclusively dedicated to passenger traffic, or as the German high-speed rail is developed to accommodate mixed traffic, so the Spanish HSR has its own specifics. In the last video we learned that the railway network of Spain was developed radially, which means it has the starting point and the center in Madrid. Well, a similar concept has been applied in the planning of high-speed network. The goal was to make the travel time from Madrid to all provincial cities less than 4 hours, with the idea to enable the service of so-called business travel. In addition, the Spanish HSR is not interoperable with the conventional rail network, as is the case with the LGVs in France. As we also pointed out, the Spanish railway network was built according to the traditional Iberian gauge of 1668 mm, while the international normal gauge of 1435 mm was chosen for the high-speed network. With this normal gauge, Spain has managed to achieve interoperability with the rest of Europe via its railway connection with France. In order to enable punctuality with the national railway network, systems called gauge changer facilities are applied, with the task of altering the train's wheel sets for operations on both gauges. For now, we won't go into much detail about this system, but if you're interested in this topic, you can check out our video called Innovation in Railways, 4G and 5G Technologies and Gauge Changing Trains. Another characteristic is that the Spanish high-speed rail system utilizes several different rolling stock technologies. Alstom TGV, Siemens Velaro ICE, Bombardier, together with Spanish CAF and Talgo. This open architecture of the Spanish HSR track and structures, using a variety of manufacturers of rolling stock, is quite different from the approach of many countries where the infrastructure is designed to work with only one and specific type of manufacturer. Such flexibility provides potential in terms of connectivity with other HSR systems and economic advantages from stronger competition, especially in situations where new train sets must be purchased. In addition, it should be emphasized that Spain is the absolute leader in the deployment of ERTMS. Since the first contract was signed back in 2000, more than 3,000 kilometers of rail lines have been equipped with ERTMS. Also, about 1,500 additional kilometers are about to start operations under this system. Years of ERTMS use in Spain definitely brought considerable benefits to the railway system of this country. In the first year of service, passenger transport recorded considerable growth, especially on Madrid-Malaga, Madrid-Valladolid, and Madrid-Barcelona lines. ERTMS not only attracted more passengers because of the reduction in travel time, but it also allowed the increase in the capacity. On these 3 lines, punctuality rates were averaging more than 98%, which attracted a considerable number of new customers. The prospect of hosting the 1992 Olympic Games and Universal Exposition gave the Spanish government the catalyst it needed to improve its rail network. In the late 1980s, the Spanish government opted for a high-speed rail network as part of the much larger modernization program. First, a decision was made to build a high-speed rail line to the Spanish province of Andalusia, which would establish a high-quality, high-capacity railway line between Madrid and Seville. Seville's hosting of the 1992 World's Fair prompted the choice of that city for the inaugural AVE line. also supposedly being the hometown of then President Felipe González, also played some role in that decision. It was then decided that the railway line must be extended to Barcelona and further across to the French border. Secondly, in 1988, a tender was announced for the so-called contract of the century, for the purchase of 24 high-speed train sets, with the requirement that Spain produces at least 80% of the necessary parts and equipment. Also part of the contract was the reorganization of the national railway industry, including factories and maintenance workshops. We will mention that Alstom won the tender, but we'll talk about the details in the following video, which will be dedicated to the Spanish high-speed trains. The development of the HSR system was, as we have already pointed out, radial with a center in Madrid, similar to a concept of the French HSR, whose center was in Paris. The construction of lines went through 4 corridors. The South Corridor's backbone was the first high-speed line from Madrid to Seville, with a length of 472 kilometers. The railway is designed as double-track for speeds up to 300 kilometers per hour. Construction began during 1989 and the work was planned to last 33 months. Although you may now think that the deadlines have been missed, they haven't. The works were completed a year earlier and the commercial use of the line commenced in 1992. The project itself was not burdened with large engineering structures, given that this line runs over 31 bridges in total length of 9.8 kilometers and through 17 tunnels in total length of 16 kilometers, crossing the plains of the southern half of the inner plateau, which is about 5.5% of the total length. At its premiere in 1992, the maximum commercial speed of the first AVE trains, Renfes 100 series, was 250 km per hour, allowing a travel time between Madrid and Seville of 2 hours and 45 minutes. It was planned to gradually increase the speed. In the first weeks, over 23,000 passengers used the new trains with an occupancy rate of 81%. A further reduction in travel time was made possible when in 1993 the speed record for AVE trains was reached at 356.8 km per hour, which allowed commercial operations to begin during 1994 at 300 km per hour on long-distance AVE trains with a duration of 2 hours and 15 minutes. In 2005, a branch line was built that connected Madrid and Toledo via this line. The next thing we would like to mention is the connection between Madrid and Malaga. This connection was realized with the existing connection from Madrid to Seville, where the connection to Malaga was separated in Cordoba. The 155-kilometer line was completed in 2007, reaching the city of Malaga and the new Malaga station Maria Zambrano. In 2015, HSR Madrid-Seville was extended to Cadiz, while the railway connecting Malaga is also connected to Granada. The northeastern corridor has a backbone line to Barcelona and further to the French border. Unlike the line from Madrid to Seville, the construction of a 621-kilometer double-track line to Barcelona, designed for speeds up to 350 km per hour, is characterized by several delays, where it was originally scheduled to be launched in 2004. In fact, the line was completed in 2008, while some sections were open to traffic earlier. Madrid-Zaragoza-Lleida in 2003 and Lleida-Tarragona in 2006. This line currently accommodates one of the world's fastest long-distance trains in commercial operation, with non-stop trains covering the 621 kilometers between the two cities in just 2 hours and 30 minutes. The line includes a spur railway that branches off at Zaragoza towards Huesca in North Aragon. The Madrid-Huesca high-speed line was inaugurated in 2005. Given that the idea was to connect the Spanish and French HSR systems, the construction contract for the international section between Perpignan in France and Figueres in Spain was awarded in 2004 for the construction of a 176-kilometer railway, of which 25 kilometers are in France and 151 kilometers in Spain. It crosses the French-Spanish border via the 8.3-kilometer Pertus tunnel bored under the Pertus Pass. The international section officially opened in 2009, but services were delayed until December 2010 because the station at Figueres was not finished. The Spanish 131-kilometer Barcelona-Figueres section was originally planned to open in 2009, but there were delays in building a 4-kilometer tunnel in Girona, the first phase of which was completed in 2010. The section was eventually officially opened in January 2013. The North Corridor includes the construction of HSR line, so to speak, to the shores of the Atlantic Ocean. The HSR line to Lyon was inaugurated in 2 stages. Its first 180-kilometer section, Madrid-Valladolid, was opened for commercial service in 2007 and is the first installation of a high-speed rail corridor in the north and northwest of Spain. The second 163-kilometer section from Valladolid to Lyon was opened in 2015. Since then, the journey time between Madrid and Lyon was cut by 44 minutes. The Atlantic Axis high-speed line was built along the Atlantic coast. Construction started in 2001 and the first section between A Coruña and Santiago de Compostela opened in 2009, while electrification was completed in 2011. The extension from Santiago de Compostela to Pontevedra and Vigo was completed in 2015, after which it was put into operation. Total length of this axis is 156 kilometers and it tracks fit to Iberian gauge, which is due to be converted to standard gauge once the Madrid-Orense-Santiago de Compostela high-speed line is fully operational. The new, rebuilt railway line permits mixed traffic with a maximum design speed of 250 km per hour for passenger trains. The new line has 37 tunnels totaling 59 km, and the longest is the 8 km tunnel beneath Vigo, which connects the line with the new Vigo-Urfey station. The connection of the Atlantic Axis high-speed line with the rest of the AVE network was achieved through the section between Orense and Santiago de Compostela in length of 87 km. Which is also built with Iberian gauge, which is put into operation in 2011, and section Zamora-Sanabria-Orense in length of 230 km, which is built with standard gauge. This connection was completed in 2021 after 20 years of construction. Southeast Corridor encompasses the Madrid-Levante high-speed network. This network includes lines that connects Madrid with the Mediterranean coast of the Levante region, especially with Castilla-La Mancha, the Valencian community and the Murcia region autonomous communities. To date, about 603 kilometers of double-track line have been completed, connecting Valencia and Albacete in 2010, Alicante in 2013, Castellón in 2018, and Orihuela in 2021. All this construction has led to the fact that as of December 2021, the Spanish AVE system is the longest HSR network in Europe and second in the world with 3,622 kilometers. On the screen, you can see how the HSR network in Spain will look like after 2023. We need to put some remarks here. These data are according to what the DIF considers to be the HSR. According to the UIC, the length of the HSR network in Spain is 3,330 kilometers, bearing in mind that, for example, the UIC does not recognize the Atlantic Axis HSR line as high speed. Bearing in mind it does not fully meet the UIC criteria. So if you find conflicting information somewhere, know that it is due to different interpretations of the HSR system. Let's put some interesting facts on the table now. Spain has about 46 million inhabitants, and if we take into account the length of the HSR network, we can point out that Spain has more high-speed lines per million inhabitants than any comparable country with HSR network. Of course, a coin always has two sides. According to available information in terms of passenger kilometers that essentially measures line utilization, the HSR network in Spain is about 25% occupied as that in France and only 30% as busy as lines in China, Germany and South Korea. If we compare with Japan, which has about 126 million inhabitants, this figure is even smaller, about 16%. As we have pointed out, the construction of the HSR network began in 1987. And over 60 billion euros have been invested since then. About 50% of this value was spent between 2000 and 2012, while in 2012 alone 5.3 billion euros were spent. There are also plans for a further 5,654 kilometers of high-speed lines at a cost of at least 73 billion euros. Regarding these plans, there are many criticisms, where it is the most often mentioned that it is better to invest in neglected commuter networks, which carries 89% of rail users, and thus achieve better interconnectivity within and between cities. Now let's see how many people were served by HSR trains. When we talk about the results, we usually single out the number of transported passengers. In the case of Spain, this is also difficult to determine precisely due to different services that Renfe offers. AVE, long-distance HSR train that runs exclusively on high-speed lines with maximum operating speed of 310 km per hour. Alvia, long-distance HSR train that runs both on standard gauge high-speed lines and on conventional Iberian gauge lines. The train changes its track gauge passing without stopping through the gauge changers distributed throughout the national network, on the links of the HSR with the conventional lines. The maximum commercial speed is 250 km per hour on HSR and 220 km per hour on conventional lines. Avant medium-distance HSR train that covers all or part of its route on high-speed lines, using in the latter case the same technology as Alvia and with the same commercial speeds. We will show the added value of AVE networks by showing data only for AVE and Avant services. About 31 million people used AVE and Avant services in 2019. That's about 1,000 passengers per kilometer. In neighboring France, for example, this indicator is about 62,000. We do not even want to mention South Korea, where this number is about 143,000 per kilometer and which has some 6 million inhabitants more than Spain. Unfortunately, based on the study from 2015, it was concluded that Spain's multi-billion euro investments made on the AVE network were neither beneficial to business nor society and did not do enough to attract passengers who would otherwise travel by air or by road. The effects achieved within Spain itself is the shift to rail that occurred when the railways took over some of the passengers who used long-distance air traffic. Based on the analysis done, it is observed that in 2019 the best behavior of the air mode has placed the share at 67% in the favor of the rail mode based on the transported passengers. This phenomenon has been observed since 2015, where although both modes continue to register similar growth, the better performance of the airlines has led to a reduction in the rail share. However, the situation of clear preponderance of the rail mode in this type of journey was not so evident in 2008, where the rail share was slightly higher and commercial high speed was almost half of long-distance services, which highlights the relevance of the commercial high-speed services whose representation within rail demand has gone from 49% in 2008 to 65% in 2019. This strong development of high speed has allowed structural change in long-distance peninsular trips, where the rail mode has been acquiring greater weight compared to the airlines. We think that's enough for today's topic. We hope you enjoyed and that you're ready for the next video in which we talk about the development and different generations of AVE trains. Don't forget to like this video, share it with your rail-loving friends, and of course subscribe to our channel and consider becoming our patron. Until the next time, goodbye.